Hello everyone and welcome to lab number 12. In this lab we are also going to work on virtual link, but this time it's going to be on the discontinuous backbone areas. And that's what we have seen it in when I was explaining about the virtual link, that we can also apply it when we have discontinuous backbone areas. So these are the points that we need to follow in this lab, but before we do that, let's go and see what is the scenario for this lab. Here you can see that we have area 0 and in between we have area 1 and also we have area 0. So these are the discontinuous areas, okay, or the discontinuous backbone areas, which are area 0, okay. We need that those two areas to be connected again, because it's area 0, it's a backbone area. That means that all routers in this area should be the backbone areas, and in this case we don't have that because we have area 1 in between, okay. So as you can see here, this is the same diagram that we were using in the lecture when I was explaining, but I just here added the IP addresses to be able to do the lab. Okay, so the mission now is to make a virtual link to allow the two discontinuous backbone areas, this area and this area, to be again connected to each other. And the virtual link needs to happen actually in area 1. Okay, so let's go and see how we can apply that. Point number 1. All IP addresses are already configured as per the graph with their bridge interfaces. So we don't need to put IP addresses, I already have done that. Point number 2, OSPF is already configured as per the graph. Also, we don't need to do anything to configure OSPF again, just to win the time. So I have already done it, and I have put every network on its area, okay, because we have here area 0 and we have area 1. Point number 3, check the routing table in each router, and do you see any problem? So let's go first to router 1, and from here we go to routing, OSPF, and then here in the route. We can see that router 1 is able to see all routes which are on his area, which is area 0. So actually his own where area 1 is located. So this area here, and also all networks on area 1, because here we have an ABR in between. So these are two connected areas. Then area 1 can see all the networks of area 1. But if we look here, he cannot see the networks of the area 0, which normally he should be able to, because they are same areas. Okay, we can see that he doesn't see the bridge interface 44.44.44.0, the network of it, and then also this network 192.168.34. So if you look here, we see he doesn't see it. Okay, that means that there is a problem. And also if we look on router 4, which is also on the backbone area, and we go to OSPF, we go to routes, we see that he's not seeing, let's say, the network of router 1, which is on the backbone area. But because the two backbone areas are discontinuous, then in this case they are not able to see each other. And that's why we need to do now the virtual link. And then again, remember, when we have discontinuous backbone areas, we have to do the virtual link on the two ABRs, which are connected from one side to each one of them. One side is connected to the backbone area. For example, router 2 is connected to the backbone area here, and router 3 is connected to the backbone area, and both of them are ABRs because also they are connected to area 1. Then we need to do the virtual link on those two routers. Okay, to do the virtual link is again very similar to what we have done in the previous lab. So we go to router 2, we go to virtual link, and from here we put the neighbor ID. In our case it is router 3, so 3.3.3.3, and we say that the transit area is going to be area 1. That's where the virtual link is going to happen. And then we go to router 3 and routing OSPF, virtual links, and then we say 2.2.2.2, and the transit area is going to be area 1. And okay, now we go to router 1 directly, and in a moment we should now see the networks coming from the discontinuous area 0 where router 4 is. You can see them here. So these are the two networks. And then also if you go to router 4, we also see the same. So point number 3, we had the problem, and then point number 4, they ask us to fix the problem. And can we see all routes now from router 1? Yes. And then at the end is the same like also last lab. We are going to put a password, but this time we are going to use this simple authentication. Okay, so let me do that again on router 2. we go to virtual links, and here we put it authentication simple. That means the password will be clear text 123456, for example. Okay, now the password is shown. If you don't want to be shown, you can just say here settings, hide passwords, and then it will not be shown again. So simple, and then 123456. From the other side, also on router 3, you have also to put it simple 123456. Okay, so in this way, now router 1, you can see, because we put password from one side and we put password from the other side, router 1 has lost the routing coming from router 4, but now we can see them again. They come up again. Okay, now if you want just also to show you very fast here, if you go to the virtual link on router 2, and we said that on router 2 we put it simple, and on router 3 we put it simple for the authentication. But if you put one of the side simple and one MD5, so it will not work, because both are different authentication types. Okay, so even though that the password here is the same, 123456, but if you put it here simple and on router 3 you put it MD5, then the virtual link will not work anymore. Okay, if you want, we can just try. Let's put it here MD5. Okay, I'll put it here MD5 on router 2, and on router 3 I will keep it simple and the same password 123456. Okay, and then we go to router 1 now. We see directly that the routes have gone and the virtual link is not operational anymore. Okay, while if we want to fix the problem, we can either go back to router 2 and we put it simple, because now it's MD5, we put it simple, or we can leave it here MD5 and then we go to router 3 and we put it MD5. So they should both of them match the same type of authentication, also the same password. And then okay, now I go to router 1, and in a moment we shall see the routes again there. Okay, it's a very important point here. They are intra-area. Intra-area, remember, that means that these are routes inside the same area. Okay, inter-area here, that means it's coming from another area. Because both areas are area 0, then the router 1 will put them as intra-area. Also router 4, if we go to router 4, you will see the same. He put here the networks coming from router 1 as intra-area, because they are considered to be the same area, which is the backbone area. So point number 5 is okay, we've done it, and then check if routings are shown again. Yes, they are shown. So by this lab number 2, we have done the virtual link completely. We have seen it how to do it when we want to connect one area to the backbone area, and it has a transit area in between. But also we have seen how to do it and how to configure it when we have to connect two discontinuous backbone areas together. Okay, so with this lab we have just finished now the virtual link completely. I hope that the lab was easy for you to understand, and I see you in the upcoming lab.